The Instructor library for function calling is amazing, and I'll try to show you why. I'll first demonstrate it by examples. Here we have this text, and on that rainy day, Michael ran towards the house. He was 21 back then. We're trying to extract the name and the age. When we run this, we get Michael and age as in a JSON format, just from this, and it's using function calling. I have this portion of the pre-med's Wikipedia article, and I can run this 26 lines of code and extract the name, location, builder, height, and builder of a single pyramid. But then I can actually extract it for all the pyramids in the text. As you see, what we get back is an object, and we're printing all the pyramids that are detected. We can also define and construct data frames from it for it using pandas, and save them into a CSV, just like this. It's pretty incredible. It also does validation, so you can get large language model to actually validate the output. Don't say objectionable things, for example. And you can also do retries based on some error. I can already hear you saying pydantic, oh my god, I don't like it. Well, that's what I thought originally too, but I'm getting really used to it, and I think it's amazing. I'll now start from the basics and explain to you what this all means. So what Instructor does is it allows you to use pydantic to define some data structure, some definition of your data. For example, you want age, name and age, and it allows you to extract that without defining cumbersome function definitions or anything like that. I mean, if I've dealt with function calling quite a lot, and I know how difficult and complicated it gets, especially with definitions, I think this is a great way to handle it. You do have to pip install pydantic and Instructor. The requirements are these. Essentially what happens is you install Instructor, and then when you call this instructor.patch, it allows you to call this response model as a parameter when you're just making a regular call to OpenAI chat completions. And this just takes care of everything. You just define your class, right? So your data structure, and then you just enter it here, and then that's it. You get very clean JSON outputs, even using GPT 3.5 Turbo, although for complex cases, GPT 4 is recommended. I will talk about pydantic too towards the end, but this is the important part. Pydantic allows you to define how data should look like using classes. That's it. That's the most important part. It also does parsing and validation, but it might seem strange at first, but actually when you just play with it for a little bit, it just can do amazing things. These code files, all of them, will be available for free at my Patreon. Link will be in the description, but if you choose to support me and become a patron, you will find over 160 interesting projects. Also, I'll be making more exclusive videos, especially about Instructor as well for my patrons. Now let's take a look at a more complex example. For example, in this pyramid example, I am again importing Instructor and pydantic, base model from pydantic, which just defines our most basic data structure, right? We do have to call instructor.patch, so we can call the response model. And we're defining a class, pyramid detail. This could have been anything really, which inherits from the base model. And then we're defining name, location, height, and builder. And we're defining their types. In this case, they're all going to be string. And I'm opening the pyramids.txt, which just includes just regular text information. Okay, that's it. So now we have defined all that, and now we're just saying pyramid is going to equal the pyramid detail, which is going to be what we're going to get from OpenAI chat completions. And we are just defining the model. Response model is pyramid detail. That's it. And that's it. We're not even specifying and instructing the model to do anything. And then when we run this, we are going to get a single instance of a pyramid detail, okay? And we do. Great Pyramid of Giza, name, location, Giza Plateau. Height is about approximately meters, builder, pharaoh, Khufu. Now, if we wanted to get a list of pyramids, then we again have the exact same pyramid class, which is going to return name, location, height, and builder. And we define another class with a list this time. Now I'm going to talk, this is not the way you want to do it. You want to import the list from typing, but essentially you just define a list. Each item within that list is going to be pyramid. If you have actually worked with function calling, this is exactly how you do it, but you have to spend so many words explaining. You have to define an array, and then each item is a string or integer, things like that. This takes care of all that, okay? And it's automatically converted to a function definition. So in this case, we're going to get a bunch of pyramids, is a list. That's the whole idea. Again, that's it. We just read the file and we give response model as pyramids detail. Okay, we do give the final list, because this list is going to include this list class. The class which defines the list is going to include this individual elements. That's it. And then we print the pyramids, which is going to be an object, right? List. And then we can also print the name, location, builder, and height of each and every one of them, because the P in each pyramids.pyramid contains each one of the items' name, location, height. We'll come back and explain this better shortly. So here we go. This is what we get. First, we get a list, right, of all the pyramids, and then we just loop over and print what we need. Now, you can actually even apply this to a general case. So I was thinking, fine, we do have a pyramids text. I know we have a pyramids text. So when I'm defining this name, location, height, and builder, I'm thinking of a pyramid. But what if I didn't know what the text was going to be about? What if the text was going to contain a bunch of different things, right? Which I might not know. Then you can actually define a general case. See, here again, we're doing everything the same, just importing a dict from typing. We're just defining a generic detail class, which is going to be a dictionary. Okay, and we give that to response model. And now here we can specify anything. Like I'm saying I'm giving it some instructions, but I'm saying extract pharaohs from the text below. But I don't have to specify pharaoh, its age, or anything like that, what time frame they were alive, things like that. When we run this is going to take a moment, and we are using GPT-4 for this. So in the end, let's see what happens. Here we go. This is what we get. We get the names of all the pharaohs that were mentioned. There's a list within a dictionary, that is. The key is pharaohs, and the value is a list of all the pharaohs. That's it. That's all we had to do. I mean, this is pretty incredible to me. And I do want to quickly mention that I have a website, www.echohive.live, where you can find all my videos. I have over 200 now. And if you're a patron, you can find the code download links easily. So, and you can do instant search over here. For example, if you're searching for GPT-4, all you have to do is type and all the videos related to it will show up. We'll be taking a look at more of the examples, and I'll explain it as best as I can. But I just found out about it very recently today in this video. Jason Liu is its creator, great guy. And I'll put the link to this video in the description. Also, the GitHub repository. There's quite a lot of examples. Some of the examples I'm using, I borrowed from here, and some of them, more complex ones, I created myself. Before we look at the data frame extraction, let's go back to the basics. Okay, so maybe this will make more sense, right? That's it. We just define a class, how our data should look like, and then we give that to the response model after the instructor.patch. And then that's it. We can give it instructions, just text. The limits are your imagination. You can also do validation. So here we are defining a class. So there is quite a lot to pydantic and all the typing related libraries. I don't pretend to know all of it, but I will be learning more and more, and I'll be making more videos on this because this is really fascinating subject. So here we are defining a class and using the before validator. We are saying, and we are using the LLM validator from instructor, don't say objectionable things. That's it. And we are using annotated. So there's just this, but our data structure is very simple. It's just question and answer. Okay. It's just question is going to be a string and answer is going to be a string, but we are giving it additional parameters almost like this. And then in this case, it's a quick try. Here we go. We get a question answer. What is the meaning of life? The meaning of life is to be evil and still. When we actually run this, we'll see that we get an error, but our error is that our assertion failed. The statement promotes objectionable behavior. So we get a large language model to return actual errors, which we can actually use. So this is very interesting. Another thing is that because we can now get errors, we can actually do retries. Take a look at this. So we are using user details, right? Name and age. And now we are using this field validator, again, from pydantic. We say name. I guess we want to validate that. And then here we are essentially saying whatever V is, which is going to be the name, we are checking if it's uppercase, and then we say name must be in uppercase, okay? So, and then we just give that class as a response model. And then we have this extract JSON is 25 years old. When we run this, we are running it one time. We have max retries 1 here, because this is also another attribute that comes from instructor. And now after running instructor.patch, because essentially we're extracting, again, name and age, and we are just going to say an extract from this. And we do get JSON, and we are here printing whatever the model, because we are receiving whatever object is a model, and then we are printing model.name, and it's JSON, but it's in uppercase. Because what happens here is that because we max retried, so we retried one time. What if I set to 0? See what happens. Now this time we got an error, we got a value error, but the error is name must be in uppercase, and we specified that error here. Name must be in uppercase. Now this is fantastic. You can really use this. So what happens here, I believe, is when you set the max tries to 1, this is fed back to the large language GPT. Okay, this is sent back to GPT. And then that's why when we set max retries to 1, so if the first one fails, the second one actually returns the name in all capital letters. So this is really fantastic. Coming back to this list example, so normally the proper way to do this is like this. Okay, we import list from typing, and then we do it like this, because it just gives you, so here the standard list, because Python does have list, but it doesn't allow defining what type of data it might contain. Okay, so that's why, which is a bit complex, I believe, at first, but that's why we are importing list from typing. But Python automatically itself has list as well. I guess at this point, I will quickly talk about pydantic. So I learned a bit about pydantic. So pydantic is a Python library which you have to pip install. Okay, these are the requirements. Which can validate data, ensure that data fits a certain structure. And that's exactly what we want, right? That's exactly why we're using function calling. That's exactly why we're defining these complex function definitions. We do want to validate data. We want that data to be parsable. Parsing means to take one type of data, like a JSON, data from a JSON object, convert it to string or something, which we can use. So you can do that. Also, most importantly, this, if you can define how data should look like, making it easier to handle and understand. For example, if you imagine you're building a website where users sign up, you want to ensure that every user provides a valid email and a password. Pydantic can help with that, right? So that's like one use case. But here in this case, we're using it with a large language model, GPT, for function calling. For example, here you can see for that use case, you can define an email and password. You make sure they're both strings, for example. So if someone tries to create a user model or user object without an email password, or with an invalid data type, which is, say, in this case, not a string, then pydantic will raise an error. So here's another interesting one. For example, here again, we are defining user, name and age. Names needs to be string, age needs to be an integer. So now we are defining a user using this class, saying name is going to be Alice, age is going to be 30. 30 is integer, so this will work, no problem. But this one will actually raise an error because the name is a string, perfect, but age is not a string. Age is not an integer. Age is a string. So that's why it will raise an error. This is why it's important to define your types when programming, and I'm finding out and learning this more and more myself. So having said all that, let's go to the data frame extraction. But before I continue further, I would like to thank to all my patrons. I have put in the last year over 2,000 hours of effort. My days and nights are dedicated to this, and I have produced over 200 videos and 160 plus projects for my patrons. So if you enjoy this type of content, consider becoming a patron. You can download the files for complex projects. These will be free. It just makes it easy to experiment and all that. And if you do wonder what type of content I have, like I said, you can go to my website, www.echohive.live, and do a search or quick browse and see if you like it. And for the patrons, I provide a quick code download link. When you click on that, it'll take you to the post. You can read all about it and also download the code. Now let's come back to this data frame extraction. So this time we are importing this OpenAI schema from Instructor. We are importing what's called a field from pydantic, list and any from typing. Okay, so what we're defining here is a row of data using OpenAI schema, which is already predefined for us. And we want a list. Row is a list of any items. Field, these three dots means that it is required. I guess you can put none when it's not required. So null values are accepted, I believe, in that case. So the description, quick description for this is the values for each row. I believe this description then also gets to be put into the function definition, though I'm not entirely sure. Then we define a data frame class using OpenAI schema, and then see we did define a row of what a row of data is, which is going to be a list of any type, I believe. So here in this data frame, this is the data frame, which is the class that represents the data frame. This class is used to convert data into a frame that can be used by pandas. So then we say that data is going to be a list, and each list is going to consist of one single row of data. So, row of data contains a list, right? So if you go to the CSV, or if you look at it in table format, say this list, like this row has 3 items. So it's like a list. In this case, this is what this does, a single row. And the data frame is going to be a list of rows of data. What that means is, if you come back here, see this is one item in the list, this is one item in the list, this is one item in the list, right? So that's what we're defining. That's what we're defining here. And we say the description for that, again, we are using a field. Correct rows of data aligned to column names, none are allowed. And then column is also going to be a string, because column names, right? Column names are relevant from source data. Should be in a snake case, it says. But essentially, the columns are going to be at the top, the labels, pyramid name, dynasty builder, right? That's also a list. So we've defined what data is, what columns are, and you can actually define methods within classes. So we're defining a method under this class called toPandas. We are importing pandas here. That's why we need pandas pip install. And then, I'm sorry, I keep going back to the wrong file every time it seems. Anyway, then we say columns are self.columns, which are this, which we have defined here. And data is row.row for row and self.data, okay? And then we return that data frame. Data is data, columns is column, using the pd.dataframe. So that's it. This is our class. This is our pydantic class. So now that we've defined it, we are defining a data frame function, which is going to take in some data. In this case, it's going to be our pyramids.txt, okay? And here we are making a completion call, right, to GPT-4, this temperature. And we now defining functions and function call. Now here we're going to explicitly define the functions and function call. But I believe, if I'm not mistaken, this response model takes care of it for you effectively. And I believe here in this case that it's defining explicitly because maybe just as an example, number 1. 2, here in this case, when we call the name of this, then we are actually forcing for that function to be called, right? And here I have a system message says map the pyramids, their build date builders into a data frame and correctly define the correct columns and rows. Now you don't even have to do this, right? In a way, I mean, you don't have to do it exactly because it has this function definition, which is quite descriptive. It also gets these descriptions, right? Then it's going to try to extract some information anyway, but I just put it there, explaining what I want. And the user is just data, just inputting data, makes tokens 1000. And then we're going to return out of this data frame dot from response completion. I believe data frame does have that method because it's defined, it's inheriting from OpenAI schema class, which we're importing from Instructor. So, and then that's we input the completion, whatever the return is, and this will actually, I believe, just parse it and everything for us, right? Otherwise, remember, in function calling, we have to do all this. Okay, if function call in this, then the name, and then you have the json.loads and all that, and then you run into parsing problems. And so this line, I believe, takes care of all that. That's the whole idea. Okay, and then now we're going to run our program. We open the pyramids.txt, right? We read it, and then we just call df data frame, which is our function. We call it with just our text, which is our pyramid text. That's right. We're just calling the function. This is actually just like calling a function. Just don't be confused, just like that. So that's it. And then we print that is a data frame. And then we make a data frame, and then we save it to a CSV file. And I had just ran this, and this is what we get. This is the print from this print statement, df to pandas. And this is the CSV, which is saved right here. And the extension I talked about turns it into a table. CSV to table extension, this one. So I hope you enjoyed this. I hope you can see the power of this. I know it seems confusing at first, but it may seem complex, but I'm only showing you the complex cases just to see what it can do. You can do much, much more than this. And I'll be making more videos. And please do let me know in the comments what you think. But I think this is great if you dealt with function calling, complex cases. I mean, it really becomes a bit of a pain. And this not only handles the definitions, now also the parsing. Now, I just want to say we didn't call any functions. Okay, you can also create definitions from a function, I believe. I didn't want to make it too complex. So we only dealt with, like, structured data extraction. Anyway, the link to my Discord, echohive Discord, will be in the description if you like to chat with us about large language models or about Instructor or about AutoGen or whatever else. And the files here will be freely available at Patreon. If you do decide to become a patron, I greatly appreciate it. And that's it. Hope to see you in the next video. Take care.